Welcome back, everyone. Today we're looking at the difference between rational and irrational numbers. Now, the technical definition of an irrational number is a number that is a non-repeating, non-terminating decimal, which is a really complicated definition. So what we're going to do is we're just going to look at some examples and try to show you the difference between the two things that way. So first, go ahead and in your notes just put together a quick little T-chart. And on one side, we're going to put rational numbers. And on the other side, we're going to put irrational numbers. Now, as we look at the difference, I'm going to show you some different examples and try to compare it to something else that you probably already know. So, for example, if we're looking at rational numbers are numbers that we do know. For example, the number 5. That's a rational number. An irrational number would be something that, for example, you already know the symbol and you already know what it means. It's the number pi, or the symbol pi. That's an irrational number because, as you know, pi goes on forever and it does not repeat. So from our definition, a non-repeating, non-terminating decimal, non-repeating means there is no repeating. Non-terminating means it never ends. So rational numbers, for example, the number 5, has a specific end. It is the number 5. That's where the decimal ends. Pi does not. Some other examples of rational numbers would be something like the square root of 9. We know the square root of 9, and we know that the square root of 9 is 3. However, we also know that an irrational number would be something like the square root of 10, because we don't know what the square root of 10 is. It's one of those decimals that goes on forever, and it never repeats. So there's an example of a rational and an irrational number. Now, if we're talking about decimals, we could say that the number 3.8 repeating is rational. The reason that that's rational is that even though the decimal never ends, it does repeat. We know what's coming next. Every number that comes after that is going to be 8. However, if we look at an irrational number, it could be something like 3.818118111, and so on and so forth, where nothing ever repeats specifically, but at the same time, it's not a terminating decimal. And you show that by putting 3 little periods right after the last digit of your decimal. So again, rational numbers repeat or they terminate, meaning they end. So if the decimal repeats, it's rational. If the decimal ends, it's also rational. Another example, just really quickly, of another rational number would be something like 5.4, where it stops after the 4. It's not repeating. The decimal doesn't continue any farther than that. The last thing we're going to look at is fractions. And the interesting thing about fractions is that every fraction is rational as long as it doesn't have an irrational number in the fraction. So, for example, if I were to give you the fraction 1/2, that's a rational number, because if we were to simplify that and turn it into a decimal, we would get 0.5, and that's a rational number. However, if we were to take the fraction 1 over the square root of 10, even though this is a fraction, it's no longer rational because the square root of 10 is irrational. So that's a pretty basic understanding of the difference between rational and irrational numbers. So the last thing we're going to do is I'm going to give you a couple of examples of different things, and you need to decide whether those numbers are rational or irrational. So here we go. Let's start with the square root of 20. And once you've figured that one out, then go ahead and try 3.85, where 8 and 5 are repeating. And then for our last example, why don't you work with the square root of, let's say, 49. And go ahead and pause the video and figure out for yourself which of these are rational or irrational. Okay, so let's look at these now. The square root of 20. So the question we have to ask ourselves is, does the square root of 20 actually exist? Meaning, is there a number that we can think of that if we multiply it by itself, it equals 20? And of course, there is not. The only thing we can multiply is 4 times 5, or 2 times 10, or 1 times 20. So the square root of 20 would be considered irrational. Okay, so now we look at 3.85, and again we go back to what we talked about earlier, and we know that repeating decimals are rational. So 3.85, where the 85 is repeating, is a rational number. And then lastly, we have the square root of 49, and the square root of 49 actually does have an answer, and that would be 7. So the square root of 49, because it has a number answer, is also a rational number. So there we go. Those are some of the more basic differences between rational and irrational numbers, and hopefully that will be everything that you need for your class. I will see you guys tomorrow.